In this episode,
I would put a mouthful of diluted glycol in my mouth.
The one for £4.50, there's 2 bottles left. The one for 20 quid is a full shelf.
To be honest with you, my mind's blown.
What great business model. A product that destroys itself.
It's a very nasty colour comes out.
And then something goes wrong, and who's to blame?
Without naming names, and I'm sure when I say this, the guys in the know will be in the know, as it were.
hi and welcome back to another episode of the award-winning Homeowners Q&A podcast. I'm your host Mars, and in this episode we're diving into a problem that doesn't get nearly enough attention: water quality in heating systems. To get to the bottom of it, I'm joined by a brilliant panel. We've got Nigel Day from Energy Solutions, Dirk Van Lennep from Blended, Patrick Wheeler from Vito Energy, and Ricky Prescott from Thorough Flush. Welcome everybody. Before we get started, we'd like to thank Blended Products for sponsoring this episode of Homeowners Q&A. Water quality might not be the first thing you think of when it comes to heat performance, but it's one of the most overlooked factors that can make or break your system. Whether it's flashing, full quality, glycol inhibitors, or system treatment, getting it right matters. Blended Products are specialists in heat transfer fluids, system protection, and water treatment, offering practical solutions trusted by installers and specifiers across the UK. You can learn more about their range at blendedproducts.com, link in the description. Thank you, Blended, for supporting this important conversation. So Dirk, let's start with you. One of the most common questions and probably things that people get wrong when it comes to the actual quality of their water inside their central heating system. People tend to use the term glycol and inhibitor. They just kind of interchange that term. Could you just tell us what glycol is and how it differs from inhibitor?
Glycol is there as freeze protection in any closed-loop water-based heat distribution system. Antifreeze is another name commonly used for it, and we all see it in our car windscreen washer fluids, but for heating systems, it's very important, especially in heat pumps where you have an outdoor unit, to ensure that there is no danger of freezing up. On the other hand, inhibitor is a multi-metal inhibitor designed to protect all the metal surfaces from calcification, i.e. calcium carbonate buildup, from corrosion and other sludge buildups that may occur in heating and cooling distribution systems.
So is it safe to use inhibitor and glycol at the same time in a system?
It is commonly done in that both of them are incorporated in one formulation that is commonly sold throughout the UK for heating systems of this nature.
So, Ricky, why is water quality just so important for a central heating system? I mean, when we put our heat pump in, it wasn't even a consideration. Nobody flagged that with us. Nobody mentioned anything. But as it turns out, it is actually quite important. Why is water quality key?
It affects all the components, isn't it? If you want longevity of a heating system, you need to put decent quality water in it, put the right additives in it if you're going to add additives, because it's commonly known in our industry, I think, some of the stats a few years ago, they were saying 75 to 80% of breakdowns are related to water quality. If you get the water quality right and monitor it, you're going to reduce the breakdowns, the call-outs, and components are going to last longer, because we're seeing boilers lasting 3-4 years, then they're going out on the garden, another one in, and it shouldn't be happening, should it? It should be 10, 15 years minimum for any heating appliance, really.
I think it's a really good point. Up until recently, I think under 10 years ago, maybe 6-7 years ago, England had the highest rate of changes of boiler, or rather we were selling more boilers than any other country in the world. And the main reason for that is water quality. The same with anything that's got mechanical elements that's got water in it. It's the water quality that's going to kill it. The amount of oxygen that's in it because of water quality is going to kill it. Pretty much nothing else you do to a boiler is going to kill it quicker, unless you make it wildly unsafe by exploding. So water quality is absolutely paramount. And what we don't want is a repeat of that time when we were buying more boilers than anyone else because they were being fitted to such a poor standard, coming back and being repeated when we're moving into heat pumps, which are a lot more expensive.
Nigel, what's your stance on water quality?
I can only echo the guys that have gone before me. It's something that we're seeing now when we go off and do the manufacturers training. They're now making a real big deal of it. Some of the big manufacturers are moving over to the heat pump side with their warranty terms from the boiler side, which is basically if there's any sort of warranty claim, any sort of test on the water quality done, if it doesn't meet that test, past standard, then the warranty claim will not be honoured. It's something that up until recently has not been highlighted, certainly as part of the pre-sales process going before, because is it sometimes considered as a barrier to the sale?
Dirk, Nigel actually mentioned something quite interesting, and that is the warranty that's often connected to the actual heat pump unit itself. And a lot of manufacturers actually demand that glycol is fitted in them. There is the counter argument from a lot of installers that glycol actually does affect the efficiencies of those systems. Does it genuinely make them more inefficient?
It does, yes. Glycol makes it more inefficient. There's no doubt about it. The specific heat capacity of water is negatively affected by introducing glycol. On top of that, glycol is more viscous than water, so the parasitic pumping load goes up. Having said that, as far as overall performance is concerned, I've been looking around for exact studies, quantitative studies of exactly what the difference is to performance of heat pumps. I'm hoping some of the other experts on this panel have found something to that effect, because I haven't found it. A lot of heat pump manufacturers are heading towards antifreeze valves, but at the same time saying you have the option of using glycol. If you have a situation where the antifreeze valve actuates, the system will partially drain. If the system drains when you're on holiday or in a second home that doesn't have someone keeping an eye on it, getting the system running again in freezing weather can be problematic. There's such a demand for glycol in this country because it's a bit like an insurance policy. Glycol gives the reassurance that, number one, your system is unlikely to drain because you've got that freeze protection. And number two, once the power comes back on or the fault in the boiler is fixed, it is very easy to get everything up and running smoothly again.
Patrick, where do you sit on that in terms of, when you guys fit systems? Is there a specific thought process as to, will one house benefit more from antifreeze valves, one more benefit from glycol, or is it just a kind of blanket approach from you guys?
I think this will divert a little bit from the focus of talking about water quality, but very quickly, a lot of manufacturers now are taking a more pragmatic approach to the risk of freezing, either with antifreeze valves or glycol, or in some cases, some of the manufacturers are now saying, unless it's an exposed location or one that's prone to power outages. I mean, I live in Surrey in London. We don't really get power outages and it's not that cold and most places are not that exposed. So fitting a mechanical antifreeze valve or valves or glycol, we don't do either. It's sometimes if it's exposed or if it's a rural location, maybe an antifreeze valve. We have never installed or put in glycol to an air source heat pump system. We only ever use it for other stuff. I think it's over engineering, and I also feel the same way about inhibitor, but we can get onto that in a minute.
Nigel, what about you? What's your typical stance on that?
I think from our point of view, we've always gone down the glycol route. I personally feel that we all accept the marginal inefficiencies created by the glycol, but it's belt and braces. It's a 3-in-1. It's a biocide, it's an inhibitor, it's an antifreeze. Why not? And then certainly for the manufacturers that we install, we tend to potentially a little bit more of a smaller outfit than Patrick. We only install one particular manufacturer, and their warranty terms are quite clear. That it will be glycol. It will be at a certain concentration, without naming names. And I'm sure when I say this, the guys in the know will be in the know, as it were. This particular manufacturer, if you want to join their service plan, will even stipulate the brand of glycol to be used, which I think is a bit overkill, especially when there are better, more cost-effective products, or not necessarily better, but equally as efficient products on the market. But I think my main concern, bringing it back to the discussion that we're having, is that we're all professionals within the industry and we're having an informed, knowledgeable discussion on the situation. The problem is, dear old Mrs. Miggins isn't informed and isn't educated. And I think all of this business with this, that, and the other, I think it detracts from the sense of them being able to understand, has my installation been done right? Am I going to be protected by the warranty that I've been told that I'm going to get on the system? And I think from the inordinate amount of servicing work that we do, the reality is far from the truth. People are using these antifreeze valves as a bypass to hundreds of pounds worth of glycol, and then saying, well, it's protected from freezing, therefore I'm just going to open the cold main tap and just fill the system and see you later. And then we're back into the argument of water quality.
The interesting thing, if you ask any manufacturer of a heat pump whether the warranty will be upheld for a freezing heat exchanger if there's a failure of the installed antifreeze valves, as far as I know, all of them will say no. If there's a failure of the antifreeze valve, although they're stipulating it has to be there, they're not going to cover you if it freezes. You're on your own anyway. So again, you should only be doing it if it's an engineering approach and take the best option for you and for that customer. And I completely agree, Nigel. I didn't mean to say or to imply that all inhibitor is always bad or all glycol is always bad. If it's a considered approach, if people know what they're doing, it can be the right thing to do. And my biggest bugbear with chemical additives in heating systems has always been, for decades, if it's the right thing, then that's great. And we use it in commercial, or if there's pre-existing degradation of the system and corrosion that's evident, or particularly difficult metals like irons and aluminiums, then it can be the right thing to do rather than just a demineralized fill. But it's not considered. In 99.9 recurring forever % of cases, it's a plumber that's bought a bottle that's probably the cheapest one he can find in the shop and just dumped it into the towel rail in the bathroom because that's what's going to cover the warranty, or that's what the customer is demanding. And it's a non-scientific approach. A bottle doesn't just do 12 radiators like it says on the back of the bottle. That's nonsense, and we all know that. So unless you can teach people on the amount of it that they should be putting into the system and the type that they should be using, it can be worse for the system than doing nothing at all.
When we had our system put in, obviously the system got emptied and it then got refilled using tap water, which now when I kind of look at what the conversations are, that A, that wasn't the proper thing to do, and B, would you recommend to people that are retrofitting heat pumps that they get their system thoroughly flushed and then filled with, cleaner water?
I say to everyone, if you put even the basic system, you should always flush a heating system, whatever you're doing with it. If you're putting a boiler on a heat pump, you should always flush it, monitor the water that's going in, and then choose the additive or non-additive system approach if you want to adopt that. So you might live in a nice area you can just fill with tap water. You might live in the not so nice area where you need to demineralize or put an additive in. But if you're going to use an additive, I would use one that's supported by the manufacturer. You've got a test kit for it because the British standard and some manufacturers want you to test for inhibitor. And that is, I would say, that's the hardest thing in the industry is the test kit. All the manufacturers wrote these regulations back in 2019. The British standards say you have to fit a filter and you've got to test for additives every year. And then there was no company provided a test kit for an additive that was easily accessible. You had to ring the manufacturer up, find out what test kit it was, what it needed. And then now there's like Fernox have put it on their bottle, but Fernox up to date, that's the only company that actually say you need to use this test kit and a little QR code. All the others, you have to literally ring the manufacturer up and get that guidance. So,
or send it off for testing.
Yeah, send it off, but that price has gone up from £30 to £60. I've had a lot of tests done over the years, and spoke to a lot of customers, and it comes back usually insufficiently flushed. Please use this cleaner, this inhibitor. So every time you spent all that money, you may as well just flush the system out. If it's 10 rads, just get it out, flush it.
It's a requirement anyway. So if you're following MIs for a boiler or for a cylinder or for a heat pump, you have to flush it. Otherwise, you're breaking regs.
Ricky, just one little point there. There is another company that provides both the inhibitor, the biocide, and the glycol with an accompanying test kit. Our company does do that. And It's a very simple test kit. You just get 50 of these straws.
What test is that, Dirk?
It's a molybdate test kit, and for each of our products, 100 parts per million on the straw will indicate that there's sufficient concentration in the system.
Is that a dose rate on your bottle? We see overdosing in new builds like crazy. They've got a full bottle of a top brand inhibitor in that's 15, 20 quid. And you know yourself, there might be 30, 40 litres in some of these new builds because they're all running on 10 mil microbore.
The answer is yes, it says on the bottle, and it also says on the glycol. It's applies to all three products that we sell, linked to the particular inhibitor that we use.
That's good then, yeah, because that's what the industry needs, isn't it? Every bottle of inhibitor, you go to, I'm not going to name any brands, but you go to a big merchant and it says complies with the BS 7593. And then in section 10 of the British Standard, it says that you must test for additives on commissioning and every year thereafter. But they don't provide a test kit. You ring them and say, oh, it's NSF approved. Well, that means nothing. It means it's been tested in a glass jar with a load of coupons in it. Now heat pumps are coming in. We're looking at system volume, radiator size and pipe size. And so we're starting to add the volume of the systems up for the efficiency of the heat pump. But usually it is just this bottle will do 10 radiators up to 100 litres. And you ask most engineers, no, they just don't go around counting litres of water in the system, do they?
All the data sheets that we publish talk about parts per 100 or parts per million.
That's good then, yeah. And I think every brand that sells inhibitor on the front shelf should have a link to a test kit or become with a test strip to test it, 2 or 3 test strips. It's not difficult, is it really? I know it myself. We go to the merchants, you've got leading brands, £15, £20, or there's one for £4.50. The one for £4.50, there's 2 bottles left. The one for 20 quid is a full shelf because everyone's buying on price, unfortunately.
Are you thinking about getting a heat pump? Then don't get caught out by a bad installation. Bodge Buster is your essential guide to asking the right questions and spotting red flags before it's too late. Written from real homeowner experience, this book gives you the knowledge to avoid costly mistakes and make informed decisions. Get Bodge Buster today in print or for Kindle, link in the description.
Mars, you've been talking about inhibitor. The British Standard suggests, and I'd be interested to get people's view on this, the British Standard suggests that for low temperature heating systems, especially if they're ever left dormant for a while, or for example, someone goes away on holiday for a month and just everything's sitting there cold, that you should have a biocide in there as well. We thought it important to incorporate a test kit that will indicate overall whether the biocide is of the right concentration as well, because it has to be the right concentration to be effective. We've combined the inhibitor with the biocide. The test kit applies to that as well. We're talking about everything being bulletproof, as Nigel said earlier on. So many households in this country have, if you flush out their heat distribution systems, that it's a very nasty colour comes out. And it also indicates that people aren't maintaining their systems properly. It's important to use chemicals to get those systems right in the first place. The best engineering solution is to use demineralized water, have very rigorous, regular servicing, and maintain a system that is has totally clean water. In the real world, we are there for protecting the system using the benefit of chemical and glycol.
I was going to ask just a quick question on the biocide testing, which has come up in my sphere quite regularly of the last week or two. I was up with Nebe in Chesterfield, and they were talking about these lightweight antifreeze glycol based products, where the term lightweight is because they're less viscous. The chap was basically saying the viscosity is removed by removing the biocide protection, which has then, with his own experience, had a significant impact on one of the ground source systems that they were called out to. I posed the same question to the AD rep that came round and saw me to talk to me about their ProCheck device, and they basically said that they couldn't do a biocide test at the moment because effectively the biocide, the nature of it is the additive effectively eats itself, and therefore a year after the line or 6 months after the line, it's very difficult to do a test on it because it might not be there because it's been incredibly effective at removing the biocides in the water.
What great business model, a product that destroys itself.
I posed the same question about biocide testing to another one of the manufacturers as well, and they seem to have the same opinion about biocide testing. So I would welcome your thoughts.
When you initially put in your combined inhibitor biocide, provided the test is done for the inhibitor and it comes out the right concentration, because it is a combined product rather than separate products,
Right.
you know you've put in enough biocide. Okay.
Right.
If you then go several years down the line and there have been biological growth in the system, you're right, you will not then be able to test separately the concentration of biocide, because it has, as it were, been consumed in its application of killing the biological growth.
Whilst I presume the actual glycol concentration could quite well be within manufacturer's limits.
Yeah. And then going back to your other point, I don't know where the Nebe guy got his impression that biocide is so viscous. First of all, there's such a tiny quantity put in there. You're talking about parts per million of the biocide we use, for example. Secondly, the biggest issue with viscosity, and the reason why we sell a detoxified, that doesn't mean it's non-toxic, it means it's detoxified. In fact, the classification is non-hazardous according to the health and safety executive. The non-hazardous product that we sell, we reduce its viscosity massively compared to the monopropylene glycols. I hope I'm not getting too technical, but the monopropylene glycols are the viscous glycols and the monoethylene glycols are the low viscosity glycols. And so what we've done is taken a low viscosity glycol and detoxified it with an additive. So that is the major issue in glycols. It's not biocide, it is the glycols themselves.
To be honest with you, my mind's blown already, and I'd consider myself to be one of exceptionally conscientious engineer that does his pre-research and da-da-da. I'm just sort of thinking the people that go before me on some of these new build sites, with what I've seen with the quality of workmanship and the price constraints that new builds are being installed at currently, I can't help but feel there, but for the grace of God, we go.
There's lack of training, there's lack of guidance, and a hell of a lot of marketing with products. And that is where the industry unfortunately went. So next week at the installer show, or the few years ago, back in June 2022, Part L came into force. Well, they put this, you must adhere to British standard BS 7593 to adhere to Part L regulations. And everyone started panicking then, oh, I've got to put this in, I've got to put in. The manufacturer saying you need to put biocide in. But like Nigel just said, there's no test kit for a single product of biocide unless it's a blend, like Blended have got. And that's the hardest bit for end users, is getting the information out there and commissioning the system, testing it, and then you've got your base data to go back to and monitor. Then the year after you go back and something's gone. To me, it's a non-Part L compliant product, and they shouldn't be sold without a test kit, because it says in Section 10 of the British Standard you have to test for any additive. Unfortunately, you can't test for it.
It was thanks to you, Ricky, when I first joined this company, that I insisted on your recommendations. So you've had a big input at Blended. Unknowingly.
It's basics though, isn't it? You look at the marketing and you go, that can't be right, because you've not given me the right kit to test for it. So if they all listen and do it, I know a few, I'll mention the name Camco are changing their bottles and putting the codes on them apparently to link to a test kit to theirs. So, and it's simple, isn't it? You take the sticker off the inhibitor, it's got a QR code on, you put it on the boiler the date it was installed, scan the QR code, there you go, it's 100 ppms and the lib date you need to test for, or 300. It takes hours to do. It's all on the computer. Simple.
Obviously, I guess the majority of people watching this will be homeowners, and then quite a lot of installers, engineers. And it'd be interesting for the installers to ask themselves a couple of questions. Why are you using inhibitor? What's it there for? And to see if they know why, or they've got an idea of why they're doing it. Is it just because they think they should? Do they know its original purpose? How much should you be using? Because they'll probably go, well, a bottle, because it says it'll do a house. And what's in it? What's the chemical? What's it doing? And if you can't answer all those questions, stop just dumping some stuff in the system. Have a bit of a read about it. Go and do some courses or get a book, do a bit of research.
People need to research test kits as well, because there's a few on the market, and I know I've been contacted by big manufacturers and their top engineers, and they're given a test kit and they're going out to the customer's house saying, sorry, love, your system's not got inhibitor in it. And that test kit only tests for one, and usually it's testing for molybdate. But you go in a lot of merchants now, and they'll say City Plumbing. They don't use a molybdate-based inhibitor in their Plum Right brand. They use nitrate. So that test kit will show a negative, no inhibitor, but it's protected with another blend. So then they tell the customer you've got no inhibitor in, and then they get kicked back for selling a bottle of X brand. And add that in the system, so you've got two different blends in there, and then something goes wrong, and who's to blame?
Ricky, I think City's been listening to you because they're changing their approach towards our approach now. So watch this space.
Are you new to heat pumps and feeding lost? Then From Zero to Heat Pump Hero helps you understand, operate, and optimize your system. No jargon, just simple practical advice from one homeowner to another. Take control of your heating and save energy. Get your copy now. Link in the description. What's got me a little bit worried here is that there seems to be an awful lot of complexity now to yet another layer of heat pumps in terms of the water quality, and it almost seems like one plumber can come in and just top up with a little bit of this, and somebody else comes and tops it up with a little bit of that, and this whole thing can start to unravel quite quickly. So are these things, or should these things be tested for as part of an annual service? Because we see that the servicing of heat pumps is becoming a bit of a shyster type area where guys are coming through, they're not really doing the proper work. Should there be a full-on test for glycol levels, if there is glycol in the system, as well as inhibitors and biocides and all that kind of thing? Should that just be standard on an annual basis?
I think Mars, you couldn't have read my mind any better, to be honest. 95% of our business is on the service and maintenance side of things, and like you say, anybody refers to the court of Facebook, they'll see an annual heat pump service ranging from 40 quid up to £440. We see it all the time. I think from our point, yes, it needs to be checked. Why wouldn't you? It's an expensive piece of kit that is sat outside your house, and not only is it expensive, it's incredibly important. It heats your home and keeps you clean. Some real fundamental, bare minimum requirements for everyday living. And I think, going back to the point everybody was making, I think the one thing that I was going to add was, not only does it need significant education within the industry, it also needs significant education within the general public and beyond. A system water test is £38. If we take it back to a gas boiler system, when the guy's only charging 70 quid for a gas boiler service, because that's all he can do, because he's competing against 6 other gas engineers on his street, he's going out for 30 quid. He's not going to do it.
I think it's important to reiterate what Ricky said earlier about the marketing side of our industry taking over and sort of superseding what is actually common sense and scientific approach, because most installers want to do a good job and leave a good system for their customer. And I think they've been led over the years to think that there are certain approaches and solutions in our industry that have to be done, and it's not the case in all cases. So I was a bit worried that we might have been selling installers short there and saying that they're taking a shortcut and just dumping in some inhibitor because they think that's the only approach. And I think actually it's because the entities in this industry that are spending the most money are the ones that sell the most stock, and they're therefore perpetuating and selling more of it and marketing more of it. And I think that's probably, along with the combi boiler, has been one of the things that's reduced the amount of engineering in our industry. I think we need to get back to that. So education is always the answer to everything, right? As long as it's the right education. So for any engineer that's watching this that is suddenly thinking, shit, what am I doing? Why am I putting these chemicals in? I need to learn. We need to have a route for that, and people that can teach them about water treatment. One of the best courses I ever did was run by a guy called Remco years and years ago. It completely opened my eyes to water quality, water treatment, what's going on in there, the effects of it, pH, dissimilar metals. It isn't that complicated. Once you've learned it and you've seen, it's relatively easy to replicate.
Ricky, what is VDI 2035?
So VDI is a technical document from Germany, and it's widespread across Europe now. I think Switzerland have their own version and Austria have their own. So it's basically talks about pressurization of systems and systems without chemicals, chemical-free approach. So you can fill with tap water. There's certain parameters in there to go for the saline range or the low saline. So you can fill with tap water in certain parts of the country, or most of the country. You can fill with demineralized water. But a lot of the manufacturers now are coming on board with it over the UK. So a lot of the products we use are European. Patrick's obviously a big Viessmann installer. Viessmann appliances don't want inhibitor in their systems, and that's where I've probably grown my business from, bringing Thoroflush to market and then getting involved with the German company. Is most of my customers were Viessmann installers. So it's just a European form of commercial water treatment, basically, and it's more adopted now in the domestic market.
Potable water is the best thing you can put in a system, right? If it hasn't got anything in there, if there's no pre-existing corrosion in the system and you're stopping any potential for bacterial growth or corrosion, that's the ultimate goal, right? We just want to stop it degrading and make sure the system works. It doesn't have to be complicated.
That is the thing about heat pumps now. People who are doing this technology of designing systems and things like that. It's like Patrick just said about the combi boiler. If you're chucking a combi boiler at a wall, it might not exactly be for you. But if you're putting a 10, 15,000 pound heat pump system in, you've probably got the expansion vessel in the right place. You've sized the pipe work, and the customer's invested a hell of a lot of money to this technology. So if it starts losing pressure, they're going to ring you up. And unfortunately, the combi boiler again, stickers on the front telling you how to top your boiler up. And it's natural that Marge, you're in the shower, it goes cold, you shout the wife down to top the boiler up because the pressure's gone. And we're constantly doing it week by week, and no one's bothering calling anyone out. It's become kind of natural now for everyone just to top a boiler up. There's automatic filling loops that do it and things like that. And we shouldn't be topping systems up. If that's losing pressure, you get on the phone to your engineer because there's a problem. It could be usually the expansion vessel's incorrectly sized, or just wants to be a simple service. We're not servicing boilers properly or heating systems. The big boys aren't doing expansion vessel charging. That has a massive impact on a heating system water quality, unfortunately, and it just gets left and left until it starts losing pressure. And we all drive past the house and see the big triangular brown stain down the wall, and that is just a simple service could have cured all that.
Dirk, you mentioned that your products are non-hazardous. I think one of the big concerns that people have is that if a system does get emptied and that water pours into their garden, just genuinely how unhazardous are they?
The concentrate version, of course, by the time it's in your system, it's between 25 and 30%. According to the health and safety executive of this country, this product is non-hazardous, which doesn't mean you can use it as a food ingredient. What it means is that in day-to-day usage, it's not going to be a threat to life or limb. And there are many more household chemicals that are much more hazardous than glycols. Just to put things in perspective, I would put a mouthful of diluted glycol in my mouth and then happily swill it around and spit it out. But I'd never put bleach in my mouth, as an example. It's environmentally not a great threat, provided that people use the normal recycling facilities for the containers, which are recyclable. And then as far as the fluid itself is concerned, it does biodegrade in the environment within 2 to 3 weeks. So it biodegrades pretty quickly.
So Patrick, as a closing word for you, in terms of if somebody's watching this as a homeowner and they are concerned about their water quality, maybe they've emptied a filter, some black sludge has come out, what would you advise to them to try and get their system rectified and running as cleanly as possible?
It's fairly straightforward. Call as many engineers as it takes before one of them says that they know what they're doing. And there's a few easy questions like we went through earlier. What are you going to do to make sure that my system is protected, and why are you going to do it? If they say they're going to put in chemicals, how much and why? Or if they're going to demineralized fill it, can they say why that's the best approach for them as well? If there's pre-existing corrosion, then you might need to use inhibitor if it's gone too far, because you can't flush all of it out. You can't stop it. If corrosion's already there, it's going to go. You can only slow it down. But just ask a couple of the questions based on what we've talked about today until one of them says confidently, we know what we're doing. Chemicals are not a bad thing if you know how to use them and what they are. And clean water is a very good thing if you know that that's the right solution as well. But any one solution has to be justified by the science behind it.
If you've got any questions about heat pumps, then you need to join the Renewable Heating Hub forums. You can connect with other homeowners, share experiences, and get advice on heat pumps and renewables. Sign up today and be a part of the conversation. Link in the description. So that's it for this episode. A big thank you to Nigel, Dirk, Patrick, and Ricky for their time, insights, and honesty. And of course, thanks to our sponsor Blended for making this important conversation possible. If you found this episode helpful, please give us a thumbs up, hit the subscribe button below, and join the discussion over at renewableheatinghub.co.uk. We'd love to hear your thoughts and give Watson, our new heat pump expert chatbot, a try. Until next time, stay warm, stay green, stay tuned. Goodbye.